Welcome back. Welcome back. Let's continue. You need to go to bathroom. So just continue there. Now it's 10 a.m. The weather is super nice outside. Now I was close to fall. I should be careful about that because I start to get an old man. I could be damaged if I fall on my floor, so I have to move around a little bit careful. I'm not falling on the floor, but I've not done this before. I'm not reading all this PDF from Wikipedia. That's something new. I started do that 1 month ago, but I had a long break because I was playing this computer game GTA 5. Oh, I was not playing the game, I was walking around the world map. Now this GTA 5 have a big island. I was walking around the island 2 times and reading Dennis. No, I think I will lose some 100 subscribers to do this. But now it's Friday, it's weekend, and I will be low on money the rest of this year, and most part of the next year I will be low on money, so I cannot do anything anyway. This is Friday the 17th. In 1 week I will weigh my body weight, and last night I did eat like 300 grams of candy and french fries, so that's not so good. But let's continue. Next time is a gas engine, fruit press, something weird, then I continue there. But that will take many days, but that's fine. I have many 100 days alone in my apartment. I got plenty of time. I don't have money, but I have plenty of time. But of course I should have got out. I should travel, meet some people or something. Not just to sit home alone, but there's nothing to do about that. Could do that next summer. Next summer I have $500 more every month. But not if I lose all my subscribers to do this, then I'll have less. Yes, continue.
Methods include threadings, compression fittings, glue, cement flanges, or welding. Handle or actuator. A handle is used to manually control a valve from outside the valve body. Automatically controlled valves often do not have handles, but some may have a handle, or something similar. Any way to manually override the automatic control, such as a stop-check valve. An actuator is a mechanism or device to automatically or remotely control a valve from outside the body. Some valves have neither handle nor actuator because they automatically control themselves from inside. For example, check valves and relief valves may have near the disc. Valve disc. A disc or valve member is a movable obstruction inside the stationary body that adjustably restricts flow through the valve. Although traditionally disc-shaped, discs come in various shapes. Depending on the type of valve, a disc can move linearly inside a valve or rotate on the stem, as in a butterfly valve, or rotate on a hinge or trunnion, as in a check valve. A ball is a round valve member with one or more paths between ports passing through it. By rotating the ball, flow can be directed between different ports. Ball valves use spherical rotors with a cylindrical hole drilled as a fluid passage. Plug valves use cylindrical or conically tapered rotors called plugs. Other round shapes for rotors are possible as well in rotor valves, as long as the rotor can be turned inside the valve body. However, not all round or spherical discs are rotors. For example, a ball check valve uses the ball to block reverse flow, but is not a rotor because operating the valve does not involve rotation of the ball seat. The shut-off butterfly valve for a Francis Turbine Gordon Power Station, Tasmania ball valve. The seat is the interior surface of the body which contacts the disc to form a leak-tight seal. In discs that move linearly or swing on a hinge or trunnion, the disc comes into contact with the seat only when the valve is shut. In discs that rotate, the seat is always in contact with the disc, but the area of contact changes as the disc is turned. The seat always remains stationary relative to the body. Seats are classified by whether they are cut directly into the body, or if they are made of a different material. Hard seats are integral to the valve body. Nearly all hard-seated metal valves have a small amount of leakage. Soft seats are fitted to the valve body and made of softer materials such as PTFE or various elastomers such as NBR, EPDM, or FKM depending on the maximum operating temperature. A closed soft-seated valve is much less liable to leak when shut, while hard-seated valves are more durable. Gate, globe, and check valves are usually hard-seated, while butterfly, ball, plug, and diaphragm valves are usually soft-seated. Stem. The stem transmits motion from the handle or controlling device to the disc. The stem typically passes through the bonnet when present. In some cases, the stem and the disc can be combined in one piece, or the stem and the handle are combined in one piece. The motion transmitted by the stem may be a linear force, a rotational torque, or some combination of these. Angle valve using torque reactor pin and hub assembly. The valve and stem can be threaded such that stem can be screwed into or out of the valve by turning it in one direction or the other, thus moving the disc back or forth inside the body. Packing is often used between the stem and the bonnet to maintain aisle. Some valves have no external control and do not need a stem, as in most check valves. Valves whose disc is between the seat and the stem and where the stem moves in a direction into the valve shut it are normally seated or front-seated. Valves whose seat is between the disc and the stem and where the stem moves in a direction out of the valve to shut it are reverse-seated or back-seated. These terms don't apply to valves with no stem or valves using rotors. Gaskets. Gaskets are the mechanical seals, or packings, used to prevent the leakage of a gas or fluids from valves. Valve balls. A valve ball is also used for severe duty, high pressure, high tolerance applications. They are typically made of stainless steel, titanium, stellite, hazelloy, brass, or nickel. They can also be made of different types of plastic, such as ABS, PVC, PP or PVDF. Spring. In Conal X750 spring, many valves have a spring for spring loading, to normally shift the disc into some position by default but allow control to reposition the disc. Relief valves commonly use a spring to keep the valve shut, but allow excessive pressure to force the valve open against the spring loading. Coil springs are normaliest. Typical spring materials include zinc-plated steel, stainless steel, and for high-temperature applications in Conal X750. Trim. The internal elements of a valve are collectively referred to as a valve's trim. According to API standard 600. Steel gate valve flanged and butt welding ends. Bolted bonnets. The trim consists of stem, seating surface in the body, gate seating surface, bushing or a deposited weld for the back seat and stem hole guide, and small internal parts that normally contact the service fluid, excluding the pin that is used to make a stem to gate connection. This pin shall be made of an austenitic stainless steel material. Valve operating positions. A seacock for cooling seawater, on a marine diesel engine. Seacocks are usually ball valves, but may be other tips as well. Valve positions are operating conditions determined by the position of the disc or rotor in the valve. Some valves are made to be operated in a gradual change between two or more positions. Return valves and non-return valves allow fluid to move in two or one directions respectively. Two-port valves. Operating positions for two-port valves can be either shut, closed, so that no flow at all goes through, fully open for maximum flow, or sometimes partially open to any degree in between. Many valves are not designed to precisely control intermediate degree of flow. Such valves are considered to be either open or shut. Some valves are especially designed to regulate varying amounts of flow. Such valves have been called by various names such as regulating, throttling, metering, or needle valves. For example, needle valves have elongated conically tapered discs and matching seats for fine flow control. For some valves, there may be a mechanism to indicate by how much the valve is open, but in many cases other indications of flow rate are used, such as separate flow meters. In plants with remote-controlled process operation, such as oil refineries and petrochemical plants, some two-way valves can be designated as normally closed, NC, or normally open, NO, during regular operation. Examples of normally closed valves are sampling valves, which are only opened while a sample is taken. Other examples of normally closed valves are emergency shutdown valves, which are kept open when the system is in operation and will automatically shut by taking away the power supply. This happens when there's a problem with a unit or a section of a fluid system, such as a leak, in order to isolate the problem from the rest of the system. Examples of normally open valves are purge gas supply valves or emergency relief valves. When there is a problem, these valves open by switching them off, causing the unit to be flushed and emptied. Although many two-way valves are made in which the flow can go in either direction between the two ports, when a valve is placed into a certain application, flow is often expected to go from one certain port on the upstream side of the valve to the other port on the downstream side. Pressure regulators are variations of valves in which flow is controlled to produce a certain downstream pressure, if possible. They are often used to control flow of gas from a gas cylinder. A back pressure regulator is a variation of a valve in which flow is controlled to maintain a certain upstream pressure, if possible. Three-port valves. Schematic three-way ball valve, L-shaped ball right, T-shaped valves with three ports serve many different functions. A few of the possibilities are listed here. Three-way ball valves come with a T or L-shaped fluid passageways inside the rotor. The T valve might be used to permit connection of one inlet to either or both outlets, or connection of the two outlets. The L valve could be used to permit disconnection of both or connection of either but not both of two inlets to one outlet. Shuttle valves automatically connect the higher pressure inlet to the outlet while, in some configurations, preventing flow from one inlet to the other. Single handle mixer valves produce a variable mixture of hot and cold water at a variable flow rate under control of a single handle. Thermostatic mixing valves mix hot and cold water to produce a constant temperature in the presence of variable pressures and temperatures on the two input ports. Four-port valves. A four-port valve is a valve whose body has four ports equally spaced round the body, and the disc has two passages to connect adjacent ports. It is operated with two positions. It can be used to isolate and to simultaneously bypass a sampling cylinder installed on a pressurized waterline. It is useful to take a fluid sample without affecting the pressure of a hydraulic system and to avoid a gassing, no leak, no gas loss or air entry, no external contamination, control. Many valves are controlled manually with a handle attached to the stem. If the handle is turned 90 degrees between operating positions, the valve is called a quarter-turn valve. Butterfly, ball valves, and plug valves are often quarter-turn valves. If the handle is circular with the stem as the axis of rotation in the center of the circle, then the handle is called a hand wheel. Valves can also be controlled by actuators attached to the stem. They can be electromechanical actuators such as an electric motor or solenoid pneumatic actuators which are controlled by air pressure, or hydraulic actuators which are controlled by the pressure of a liquid such as oil or water. Actuators can be used for the purposes of automatic control such as in washing machine cycles, remote control such as the use of a centralized control room, or because manual control is too difficult such as when the valve is very large. Pneumatic actuators and hydraulic actuators need pressurized air or liquid lines to supply the actuator, an inlet line and an outlet line. Pilot valves are valves which are used to control other valves. Pilot valves in the actuator lines control the supply of air or liquid going to the actuators. A sailor aboard a ship operates the wheel controlling a fuel valve. The fill valve in a toilet water tank is a liquid level actuated valve. When a high water level is reached, a mechanism shuts the valve which fills the tank. In some valve designs, the pressure of the flow fluid itself or pressure difference of the flow fluid between ports automatically controls flow through the valve. Other considerations. Valves are typically rated for maximum temperature and pressure by the manufacturer. The wetted materials in a valve are usually identified also. Some valves rated at very high pressures are available. When a designer, engineer, or user decides to use a valve for an application, he/she should ensure the rated maximum temperature and pressure are never exceeded and that the wetted materials are compatible with the fluid the valve interior is exposed to. In Europe, valve design and pressure ratings are subject to statutory regulation under the Pressure Equipment Directive 97/23/EC, PED. 2. Some fluid system designs, especially in chemical or power plants, are schematically represented in piping and instrumentation diagrams. In such diagrams, different types of valves are represented by certain symbols. Valves in good condition should be leak-free. However, valves may eventually wear out from use and develop a leak, either between the inside and outside of the valve or, when the valve is shut to stop flow between the disc and the seat. A particle trapped between the seat and disc could also cause such leakage. Images. Globe valve. A valve controller by a wheel, on vertical line. Large butterfly valve. Cast iron butterfly valve. Cast iron butterfly valve. Hazelloy ball valve. Stainless steel gator valve. Stainless steel gator valve. Hazelloy check valves. Duplex ball valve. Inconal gate valve. Stainless steel wafer check valve. Inconal check valve. Stainless steel ball valve. Cryogenic 254 SMO gate valve. Inside view of a tilting disc inconal check valve. Duplex ball valves. Cryogenic super duplex gate valve frozen up during operation. Super duplex ball valves. Flanged nozzle inconal check valve axial check valve. Inside Hazelloy kick valve, wafer configuration. Large carbon steel swing check valve. Disc for an alloy kick valve also known as axial check valve. Balls for alloy ball valves. Wafer check valve. Nuts and bolts for incolloy valves. Inconal check valve S-springs. Ball for a titanium ball valve. See also. Ball valve flow control device. Control valve flow control device. Directional control valve. Endobronchial valve, medical. Four-way valve flow control device. Hydrostatic test, non-destructive test of pressure vessels. Pipe tubular section or hollow cylinder. Piping system of pipes used to transport fluid.